Okay, here is a third vector components example. It's a bit more complicated. Elizabeth Bennet and Caroline Bingley decide to take a turn about the room in order to show their figures to greatest advantage. They walk 3 meters at 45 degrees north of east, then 5 meters at 50 degrees north of west. What is their resultant displacement? And brownie points if you know who I'm talking about here. Okay, since this one is a little complicated, it's best to draw it as much to scale as you possibly can. So I'm going to get out my ruler. And I am going to say that each centimeter is going to be equal to a meter. So I'm first going to draw that 3 meters at 45 degrees north of east. And I do not have a protractor, so I'm just going to pretty much guess. So I want to go about 45 degrees, and then I'll draw it from 12 to 15. That would be my 3 centimeters. So they started here, and then they went 45 degrees north of east. Okay, then it says they walk 5 meters at 50 degrees north of west. So that little blue line that I just drew is our western line, and they went 50 degrees north of that. And again, I'm going to use my ruler. So I'd say that's about 50 degrees. And I'm going to go from 15 to 10 for my 5 meters. Okay, so they end up here. So this green line, my pen wants to work, is the displacement that I want to find. And that blue is getting all over the place. Sorry about that. Let's go back and label these. So this is 3 meters. This angle is going to be 50 degrees. And that's going to be 5 meters. All right, we want to break this up into components. We want to find out how far Miss Bennet and Miss Bingley went in the x direction and how far they went in the y direction. So let's just try to visualize this for a second. It looks to me like from their starting point, they went this far in the x direction and then that far in the y direction. So essentially we're trying to figure out this triangle here. And that's pretty easy to do if we use components. So this is going to be our vector A. This is our vector B. And we'll call this vector C. That's our resultant vector. And I'm sorry, I'm getting blue all over the place. All right, so vector A, does vector A have an x and y component? Yes, it does. Its x component looks like that, and its y component looks like that. So we're going to say AX is equal to, and you should be able to figure this out by now, it should be 3 times the cosine of 45 degrees. So that is one of the main rules of components. When you're finding the x component, you use cosine. What about for the y component? AY, you know what, I'm going to write it down here. AY is equal to 3 times the sine of the angle. So you always use sine for the y component. Now I calculated this earlier. So since it's a 45-degree angle, they'll both be the same. So that's convenient for this problem. All right, let's do that B vector. Okay. What do we need to remember about west? West is negative, so we want to say this is equal to negative, again, because the x component of B is pointing in the negative direction. So it's going to be -5. And what's our angle for B? Our angle for B is 50 degrees. So times the cosine of 50 degrees. Calculated that and got -3.214. And then BY is going to be 5 times the sine of 50 degrees. So for that, we get 3.83. Okay, now we want to add the x components and add the we want to add the x components and the y components. So to get cx, we want to add ax plus bx. So that's actually going to come out with a negative number, -1.093. And then cy is going to be equal to 2.212 plus 3.83, and we get 5.951. Okay, so basically what we found, this here is our cx. So we found out that overall, Miss Bennett and Miss Bingley went 1.093 meters west, and they went 5.951 meters north. Remember, that's what this negative means. It means they went west. So now we have two sides of the triangle, and we can use those. Sorry, let me just write this in here. We can use those to find the hypotenuse. So the magnitude of C is going to be equal to the x component squared plus the y component squared, and all of that in a square root. And you should get 5.85. Now, we have to be careful about the angle here. Essentially, what we want to find is the angle between the starting position and between where they end up. So that would be this angle here. Now, this means, so this is the western line. That means that Miss Bennett and Miss Bingley went a certain degrees north of west. So we already figured out our direction where it's going to be north of west. Okay? Now, notice this is why I drew it to scale, so we can more clearly see where they end up in relation to where they started. All right, so to do that, we need to take the inverse tangent of the y component divided by the x component. This is just going to be your general formula for finding the angle. So you may want to copy that down. So in this case, the angle is going to be equal to the inverse tangent of 5.951 over 1.093. And if you recall, you don't need to put the negative in there because the direction words take care of that. And if you do this correctly, you should get 79.59 degrees north of west. So this whole thing is our final answer. Elizabeth Bennet and Caroline Bingley's final displacement is 5.850, and I forgot something here. I forgot my units. 5.85 meters at 79.59 degrees north of west. Whether or not it will bring them closer to Mr. Darcy is anyone's guess.